Welcome to this session on container networking. My name is Sai Chaitanya. I'm a product manager with the NSX team. The goal of today's session is to introduce networking in container platforms like Kubernetes and Cloud Foundry. There's a lot of application transformation that's going on and adoption of cloud-native platforms. This introduces some challenges. We want to introduce the NSXT platform to you and showcase how some early customers are looking to adopt the platform to solve container networking challenges. So there's a lot of application transformation going on in enterprises. So over the last 18 to 24 months, we've visited a lot of you guys. I see a lot of familiar faces, trying to understand what's really happening with containers and how they're valuable. We see a common pattern among a lot of our customers. Applications that were currently written in the traditional web app DB architecture are constantly being replatformed to a more modern architecture that is based off microservices. These are typically your Java, .NET based applications running on a traditional application server, being replatformed, modernized to a more modern or open source based application platform that could be based on either Cloud Foundry or Kubernetes. This is being done for various reasons, right? To deliver more agility, to deliver faster changes to applications. And there is a lot of traction for application transformation or net new applications written in the form of microservices. What makes them really interesting for organizations, right? So this is not just for app dev organizations, but goes a lot way up in the organization to even to the C-level executives, is the fact that cloud-native application platforms enable end-to-end automation. The experience that developers today desire is of the following. Developers want to deploy code, and all of that needs to be done to bring this application online, whether it's deploying compute, network, storage, load balancing, services, everything is desired to be automated. And the developer instantly expects the application to be deployed and gets his URL to access the application. This is the level of automation that developers today expect. This is the level of automation that platforms like a PaaS or a CaaS do offer to developers. And with this level of automation, they're able to build new features and deliver revenue streams. A cloud-native application platform automates all of the things that traditional enterprise IT did to bring up an application online. And platforms like Kubernetes and Cloud Foundry have had immense traction in the last 24 months. Developers across all organizations, right? It's not necessarily restricted to software organizations. Whether you're a bank, financial services, retail, manufacturing, every company is going to be transformed to a software company. And developers across all these organizations love these platforms because of the level of automation they provide. So while that is the desired level of automation and experience that developers want, the infrastructure that we have built in our traditional data center, be it on the compute side, networking side, or even the security side, do not really offer that level of automation. Right? Nor do they have the level of integration to be able to kind of take an application code and deploy a complete application and return back a URL. Our traditional infrastructure today does not actually offer integration into this modern application platform either. So what ends up happening as a result is cloud-native application platforms implement some form of networking, some form of security, some minimum form of security, some form of load balancing. And they deliver value, right? So cloud-native platforms are seen as extremely successful in organizations, Cloud Foundry, Kubernetes, and all of them. But what happens as this thing grows across multiple, over time, is you have multiple groups within the organization wanting to adopt different platforms. So pretty much in any large bank or any large institution, you see some groups doing Kubernetes for app dev, some groups doing Cloud Foundry, some groups may be doing Mesos. So over time, the number of such foundations and clusters also constantly grows, right? So you now see large banks having like 30, 40 foundations. Over time, this becomes a source of multiple touch points for operations. So every foundation or every cluster becomes something that is managed individually. In a lot of these cases, you also lead into certain compliance and security challenges when doing cloud-native apps that are not really integrated well to the data center. And we'll look at some of these challenges in a bit. So cloud-native apps deliver immense value to the business and hence the traction and interest. However, they're complex to integrate into the traditional data center. They introduce operational challenges, okay, when not really integrated into the data center. So that leads to the question really in terms of how should networking and security platforms evolve to support the business initiatives and to support the desired level of automation. How do infrastructure teams participate in digital transformation, right? So that is really what we were trying to understand over the last 18, 24 months, trying to understand all this cloud native space, the expectation of developers. So that learnings have really gone into the NSXT platform. NSXT is a networking and security virtualization platform for both traditional applications and modern cloud native applications. It could be containerized applications running on various types of containerization technology. It could be Kubernetes Cloud Foundry. It could be something else later. Traditional VM-based applications. But what it does really is it introduces a native networking stack to containers. Today, containers run inside virtual machines, right? Container hosts are predominantly virtual machines. Some customers are looking to do bare metal containers. Predominantly, they are virtual machines. But containers do not have a native networking stack. What I mean by that is containers are not really visible to the data center network. Your physical firewalls or load balancers cannot leverage containers. NSXT introduces native container networking. So this is something that's brand new, right? Ability to do native container networking. More importantly, it introduces a common operational model for all applications in the data center. vSphere, container, and other KVM-based applications as well. And you'll see some of these details as we go. It integrates the container applications to the rest of the data center. So all of the investments that you've had over the years in terms of tooling, processes, capital investments, in terms of maybe say physical firewalls or load balancers in the form of F5, which you'll see a demo today, they all can be leveraged for containerized applications as well. So we really learned from you that you would like to reuse what works well, right? And we'll see a customer use case of a customer wanting to use F5 with NSX container networking. So NSXT, in a sense, networking for both traditional and cloud native applications. These are some of the sessions that you should see. The remainder of this session today really focuses on why we are building this application platform integration, what use cases we're trying to solve. It does not focus on how the product actually works. To do that, I'd recommend you to read or go to the session NSXT Deep Dive, and NSXT Architecture is a good introductory level session. So how do you manage the infrastructure as if you managed a cloud native application? So platforms like Kubernetes and Cloud Foundry offer a fantastic platform for the developer to build, deploy, operate, scale, upgrade applications, right? Really, they are very great platforms to do DevOps. How can networking also look like cloud native infrastructure was really the problem statement that we were looking at. And all of that has gone into NSXT. And we'll look at that today. NSXT offers a native container networking stack. It offers the ability to do security at the container granularity. For a lot of customers, the lack of network segmentation is one of many major challenges for doing containers and proliferation of containers. So we'll see how NSXT tries to solve some of that. Load balancing is fundamental to microservices-based applications. So as you decompose applications into more loosely coupled applications, load balancing becomes very critical. So we'll see how NSXT works there. Monitoring and troubleshooting is a major challenge that we learned from customers, right? So we said, today, containers are running inside these VMs. We really don't know what happens. We like to have a tooling that gives us complete visibility into this infrastructure. So we'll see the work done with NSX there. Integration with existing tools and processes in the data center. And last but not the least, reference designs. As you would like to deploy these environments, you would like to have guidance. That's what we learned from you, that in terms of how to deploy this infrastructure, how to design this infrastructure for to start off and to scale. So all of these are fundamental required elements to operationalize containers in the data center. This is our view, right? And that has gone into NSXT 2.0, and we'll look at all these pieces. Let's start with container networking. Today, we learn that containers run on a container platform on some form of a private network. So to talk to a container, you typically send traffic to some node that node does network address translation or NAT to send traffic. So as a result, what happens is you do not have the ability to have direct layer 3 reachability between like your firewalls and load balancers and your front ends. Right? A lot of customers are looking to move Kubernetes front end tiers or web tiers first into Kubernetes because those are the easiest applications to lift and shift into a Kubernetes platform. So a bigger challenge is also the fact that whenever traffic leaves a container platform, there is NAT happening on every container host. So if you had these two containers in one VM, and if the traffic was leaving from one of them outside the VM, the traffic would SNAT out to the VM's IP, and all of the application identity would be lost. So for years, we learned that you have been following procedures for compliance for HIPAA and PCI by identifying applications using subnet and IP address. So that is something that is cannot be done as well. So lack of a native networking stack for containers, where containers take the networking stack either of a VM or implement a private networking stack. What we intend to build is to make containers a part of the data center network, right? Containers should not be special at all. So for that, we really have built two features. One of them is called the routed mode. So in the routed mode, what you're seeing there is the fact that containers, VMs, bare metal databases, and appliances, all of them share the same network address space. They're all talking to each other over a layer 3 network, which is probably routing with BGP. So at this point, when traffic leaves that container platform, you can actually identify that application throughout your data center by the subnet of that Kubernetes namespace. So native container networking, routed mode. What we saw was also interesting for some customers was this private container networking. So this is a little different from what I introduced earlier. So in this mode, what's really happening is each of these Kubernetes namespace gets one identifiable SNAT IP. And this SNAT IP is routed inside the data center fabric. So if you were to deploy one microservice or one app in that Kubernetes namespace, all of the traffic leaving Kubernetes will always take the IP address of that namespace. So you're able to identify that app throughout the lifecycle, throughout the data center as it goes. So some customers said this is quite interesting to them. And the use cases for them are quite varying, right? So one use case is as we go into all of these large enterprises, large banks, the routable address space is very, very short. It's depleting. So what some customers told us is we would like to have this private container networks, but still have the ability to identify the application with an IP address. So that's one use case. The other use case is the container environment is fairly dynamic. Applications being deployed, scaled, deleted. Traditional network infrastructure teams said we want to keep the core network stable. We don't want container environments to keep advertising subnets and pulling subnets off and have such a dynamic environment. So private NSX container networking, which gives the ability to identify an app or a namespace with an IP, meets those use cases as well. So two forms of networking for containers where the application is identified throughout the data center network. So let's look at how this is actually done. So what we have here is 3 screens. So one of it is basically the top one on the top left is simulating like a physical router. The one below is a Kubernetes namespace where a developer is actually creating apps and deploying his applications. What you're seeing on the right is NSX. So the idea of this demo is to show the native experience of the Kubernetes user is 100% the same. So as the developer is creating a namespace, a network is being created for him dynamically in the background. That is the objective. And we want to show that for both the NATed namespace and the routed namespace. So for each Kubernetes namespace, NSX creates one network and one router, right? So what we'll do is we'll first create a NATed namespace in Kubernetes, and that is the default. So user goes into Kubernetes and creates like a namespace, which is the equivalent of a project. What happens in NSX is dynamically an IP address is allocated for that namespace, and a /32 is advertised. So anytime traffic leaves a container or an app that is deployed to the namespace, it's always taking that IP address. So what NSX did is it went and dynamically created a network, a router. It used a private IP address space, 10.4, for that network. But what's really interesting here is it configured NAT. It configured NAT where it said anytime traffic leaves from the 10.4 address space, it's going to take the 172 address space, which is routed in your data center fabric. So you get one IP address for the namespace. So that second use case is really to deploy a routed network. And you're doing this using Kubernetes labels. So as you deploy a create a Kubernetes namespace, you're creating it with a label or an annotation saying that we don't want SNAT. And when you do that, what happens is NSX actually takes an IP address or an IP subnet from the NSX IPAM. So we've enhanced NSX to have an IPAM functionality. So when you set up the cluster, you actually borrow an entire subnet from your primary IPAM. And what NSX does is it does IP management for your entire Kubernetes cluster. So in this case, it actually took an IP address from your routable data center fabric and actually allocated and advertised a/27, which is again configurable into the network. So two different modes, completely routed, no form of NAT, and one where you actually have one routable IP address per namespace. Okay? So in this case, there is no NAT being configured. That was native networking. Any questions? Is native container networking valuable? Is this something that is valuable to you guys as you look to deploy containers? The ability to identify an application? Okay. The second aspect, microsegmentation. So we learned from you that as part of this application transformation, you're looking to refactor applications to more loosely coupled applications. So what used to be many tiers of a Java app running on a traditional Java server like WebSphere and exposed with one endpoint now becomes many REST endpoints. Each of them is talking to each other over the network. So what used to be IPC communication on a traditional application server now is happening over the data center network. The implication of this is the surface of attack actually increases quite significantly. So we hear from a lot of customers that we like to have a solution that allows us to secure each of this REST endpoint as it's deployed. Containerization allows us to share a single container host, a single virtual machine for many different applications. The container runtime provides file system and file system isolation for containers, but you still need network isolation for containers, right? So a lot of customers have really said one of the major challenge for them is network segmentation for containers to be able to deploy heterogeneous type of apps on the same container host. An example for this is you have a same container host VM, you want to share the VM for retail banking and investment banking, or you might want to have PCI and non-PCI apps. So the ability to do network segmentation is almost like a requirement that as we learn from a lot of these use cases. We learned from your applications that in almost all cases, these microservices are reaching out to VM-based application services, right? Or in some cases, they're also going out to your traditional system of record, which is your mainframe, right? So the network and security solution that you're looking for in many cases was something that works for VMs, containers, and bare metal solutions. Last but not the least, that what was most important is these microservices are more dynamic in nature, right? So you're trying to update these applications all the time. So the security infrastructure that you're looking for these modern applications also needs to enable automation, right? So as you deploy an app, you're looking to update the application and update the network security. So think of if developer writes a new feature to send an SMS message anytime a bank check is cleared. And typically these days, these type of messages are sent using Twilio or some external apps. So you're talking outside of your DMZ. So while your app deployment or app upgrade is all seamless, if your network firewall update is a ticket, you've actually broken the entire cycle. So the goal is to have end-to-end automation to move from version A to version B. So we learned that these are the typical requirements as you go and build new enterprise architecture for cloud-native apps. So we kind of looked at it in a little more detail in terms of what the product should actually support to kind of meet like a solution. So we learned that in most cases, you're looking to do segmentation, network segmentation between multiple apps running on the same container cluster. So this could be one container cluster based off Kubernetes or Cloud Foundry. You're looking to do segmentation within the same cluster. But in reality, for customers who have spent a lot of time doing this, like 12 or 15 months, you have many, many foundations. So you need a solution that works across multiple foundations. And last but not the least, you actually need a solution that also works for VMs and bare metal appliances. So that is essentially what we're trying to build with NSX. So the key difference with security traditionally is you deploy an application first and think of security as an afterthought. With containers, right, you're actually capturing the entire application in a manifest, right, in terms of what Docker images need to be deployed, what's the type of memory it needs, what's the type of resources, network resources it needs. So there's really an opportunity very early in the cycle of containerization to define security for each microservice. That means what apps that this microservice can reach, who are the authorized subscribers of this microservice. This can be done upfront as you start the journey on containerization. So we have two different approaches for configuring security on these containerized apps in the case of Kubernetes, right? So NSX 2.0 offers integration with Kubernetes. The first workflow is to use the cloud native app platform's policy language, right? Which is basically using Kubernetes network policy. So as you build an application in a manifest, you also capture the policy in using Kubernetes network policy. So when a developer goes and deploys an app into Kubernetes and deploys a network policy, what NSX does is it translates this network policy intent into implementation. Kubernetes network policy is only intent. It's only a definition of the network policy. It's not implementation. So NSX translates that to an intent, and it uses the primitives, right? So distributed firewall, which earlier used to be applied on a per VM basis. Now it can be applied on a per container basis. And you use the traditional firewall section and security groups constructs. The Kubernetes network policy in the current state, right, is not amenable to do policy across multiple foundations or doing policy across like a Kubernetes app and like a app that is external to Kubernetes. So it's very, very friendly to fit into the lifecycle of the developer, and a lot of our customers are looking to do it. But here are certain use cases that you cannot do it as things stand today, and things will evolve. So if you're looking to see a demo of this, we'll have this in the booth. You should go to the booth and to see how you can deploy an app with Kubernetes network policy and NSX implements microsegmentation. The second workflow is more amenable to infrastructure operation teams that configure policy on NSX. So we learned that from a lot of you guys, the infrastructure operation teams is supporting VM-based applications, some applications on Cloud Foundry, some applications on Kubernetes, and you like to have a single console for configuring all application policy. So using the NSX APIs or NSX UI is a good mechanism to do that. And you typically do that by configuring security policies using security groups. And what NSX has is called dynamic membership of security groups. So we have the ability to define security groups that are based on tags. And as you deploy apps and resources that have matching tags, this security policy is applied to those applications. So what you'll see later in a demo is we'll define this policy on NSX using NSX tags, and we'll be mapping apps with Kubernetes labels to NSX tags, right? So this approach of configuring security works for all of the use cases that we spoke about earlier. So multiple foundations, works for Kubernetes, works for Cloud Foundry, works for apps where apps are reaching out from these container clusters to backend databases. Load balancing. Load balancing, as we spoke, is quite critical for this containerized infrastructure. Now, there are two types of load balancing that need to happen on the container cluster. One is basically for traffic going from outside of the cluster to a Kubernetes app, right? So think of you built like a web application or an e-commerce application. The front end of it is in Kubernetes. So you need north-south load balancing. And then there is intra-cluster traffic, right? So it's like, think of it as inter-microservice traffic. So today, NSX implements the intra-cluster traffic or inter-microservice load balancing in the case of Kubernetes using Open vSwitch. So you have these container hosts, which are all Linux-based container hosts for now. That's what we're trying to build for in the first step. And then each of them runs Open vSwitch. And as you try to load balance between two microservices, you use the Kubernetes service abstraction. So the Kubernetes service exposes an app, and then when you do that, and in this case, when you talk from this user identity app to like that shopping cart app, traffic is actually being load balanced using Open vSwitch to those backends. In the case of external load balancing, right? So you're trying to access like a front end or application, NSX interoperates with any load balancer that works with Kubernetes. So all of the load balancing solutions today actually have an integration with Kubernetes. And the beauty of this integration is, it's not beauty of NSX, it's the beauty of Kubernetes is anybody who's built, any load balancer that has built an integration with Kubernetes, it works with anybody's container network. So as a function, NSX container networking works with any front-end load balancing, okay? In the case of Cloud Foundry, load balancing is not really pluggable for third-party solutions, right? So this is true for both east-west load balancing within Cloud Foundry and north-south load balancing. So a third-party SDN really cannot implement that load balancing. So east-west load balancing typically is done using client-side load balancing in Cloud Foundry applications. And north-south load balancing is implemented by this appliance called GoRouter, which is part of the core Cloud Foundry infrastructure, okay? So NSXT 2.0 doesn't implement north-south load balancing in the case of Kubernetes. And in the case of east-west load balancing, it implements it using Open vSwitch. Any questions so far? Networking, security, load balancing for containerized applications. How many of you are looking to do Kubernetes or looking to dabble with Kubernetes or running Kubernetes? Is this quite something of interest to you guys? Do you guys see network security as like an important challenge for Kubernetes-based applications? Okay. Native container networking, we saw two modes. One is routed mode, where you actually advertise the entire container network. The other one was advertising one SNAT IP per microservice. Any preference on one versus the other? How many would go for like SNAT IP per network? How many would like to have all of the container networks visible through the entire data center network fabric? Okay, cool. So those are the fundamental tenets of what NSXT has done for containers, right? So containers today are not visible to the data center networking fabric. What we're trying to build is keeping the developer experience of deploying an app, getting back a URL, which was earlier done without really integration into the data center network. We want to bring those containers into the data center network, but still preserve that application experience. If we do that, how will that look like? So that is the next demo, right? So cloud native applications on a data center network. So what you're going to see here is a demo where we'll actually deploy an application. We'll show you the developer experience of what really developers want to do with Kubernetes, right? So they want to create this namespace, they want to deploy an application. It might have a front end, right, some form, which is presenting some form of a UI. There's some form of application server running inside Kubernetes. They just want to deploy this application and access the application via the URL. But what NSX will do is, when you run this on a cluster with NSX, all of these containers are plugged into that 172 network, which is routed into your data center network. NSX configures the security on a per container basis. It basically makes sure that the UI app accesses the app backend on a specific port, specific protocol. The app is opened only to UI. So you're implementing microsegmentation for containers, but you're also implementing microsegmentation between a container and an external app. In this case, it's a Redis VM. Okay? So the goal of this demo is really to show the application, how do we preserve the application deployment experience, yet plug the containers into the data center network, which thereby gives us the ability to have one single operational model for all applications. and also allows us to do security for these applications and have visibility and monitoring. That is really the goal of the demo. So let's look at it. So this is a Kubernetes cluster that is running on vSphere. You have couple of Kubernetes nodes, one master node. We've pre-deployed a Redis VM here, okay? So there's a Redis VM that is pre-deployed. This is the NSX console. You see the logical switch is our language for network. So you see a network and there's a port on the network for the Redis VM. So we'll start off by really deploying the application, right? So the Yelp app already has a namespace created. Remember we said that whenever you create a namespace on Kubernetes, we create a network and have it ready for applications. So what we're going to do is start by deploying the application. Before that, we're just setting the context to the namespace. And what you're going to see now is really the experience that developers want. They want to have the ability to define the application in a manifest in Git and deploy this application on a Kubernetes endpoint. They do not want to create VMs. They do not want to use APIs, even though they're cool EC2 APIs to create networks. The levels of abstractions have risen. We do not need to be creating networking infrastructure, but there's a lot of networking happening in the background. So what you're going to see now is the application deployment experience, right? So a developer is going to deploy an app by pointing to his Git, and his Kubernetes app is starting to deploy. So this is a cluster that is backed by NSX. So all of the networking, security, IP addressing, load balancing is going to be done on the fly by NSX as part of this application deployment, right? So this app has a UI front end, an application back end running on top of Kubernetes. So the app got deployed. What you got there is a URL, right? So you go to the URL, you access the application, right? NSX meanwhile created a port for the UI, a port for the backend, plugged the container into the network, advertised that network with BGP, right? It configured load balancing, it did a bunch of things. But what was returned to the developer was a URL, right? So this is the infrastructure admin's view of things, right? So the infrastructure admin, who in the past had no idea of what's actually happening, now gets complete visibility of the applications running on that Kubernetes cluster. So you know exactly the name of the Kubernetes app, you know the cluster it's running on, you know all the labels that the developer deployed the application with. So all of the application cluster and application context is available to the network virtualization platform, and you'll see why that's valuable later, okay? So dynamically, as part of this application deployment, I said we'll also tag these applications with Kubernetes labels. So what we did is we had security groups in NSX based on tags. And these security groups were used in firewall policy creation. So this is the traditional NSX UI for firewall. It's not super clear. But ideally what you're seeing there is it's saying two UI applications should not be talking to each other. UI should be talking to an app server on a specific port. App server should be talking only to the database. So it's basically specifying the policy that you would apply for any application, right? In this case, the application happened to be a Kubernetes application. And these security groups were defined with dynamic membership based on tags. And NSX in the background translated Kubernetes labels into NSX tags. Okay? So the idea is you open up only the required set of network connections, deploy the application, and you'll be able to access the application. So developer deployed an app, got a URL, now he's accessing the application, and you're seeing that he's able to vote stuff there, so he's basically writing to the backend Redis database. And if you were to basically misconfigure any of this network policy, or the developer did not apply the right labels, and we're just going to simulate that by updating the firewall to show a misconfiguration on the firewall, what you'll see is the application will not have the required network resources. So the database, you're not able to vote on this app because you're not able to reach the database. So the idea is really, how do you deploy an app with the right set of labels and you get the minimum set of resources? What we also want to show is, how do you troubleshoot in this type of scenarios? So in this case, the firewall admin misconfigured the policy. So in this case, if the developer said, my application is not working, and I have a Kubernetes backend, and the database is some Redis external VM, you have this tool in NSX which is called traceflow. So traceflow gives you the ability to do a network trace for simulating application traffic. So what you're doing here is simulating application traffic between the Kubernetes app server, and the Redis database. And when you do that, NSX is basically testing the entire path between these two apps and trying to figure out where traffic is being dropped. And what you see from NSX is a specific distributed firewall rule, number 1085, is actually dropping the traffic. So the firewall admin can go back to NSX and look at modifying the rules. And now, when you go back, you should be able to access the application. So, to summarize, what you saw there was the experience of deploying an application that developers desire, right? So they're not really creating any form of infrastructure, not even with an API. They're deploying applications. And that is a Kubernetes API endpoint. It could be on vSphere, it could be on cloud, it could be anywhere. And that is the experience app developers want. But what NSX does is, just like how Kubernetes acts as a DevOps platform for developers, NSX basically automated all of the network security load balancing creation for the application. So together, they're able to do automated service delivery, right? So monitoring and troubleshooting. So you also saw some amount of monitoring and troubleshooting as part of the demo. So you saw that when a firewall was misconfigured, or if the app was not deployed with the right set of labels, you could have, your app might not work. And how Traceflow can help you trace the path between application containers running on Kubernetes and backend external VMs. But there's more work that is being done, right? So with NSX, what you get really is one network. And that one network lets you service VMs, containers, and future other types of endpoints. That one network also gives you a common set of tooling, right? It gives you, just like how a traditional network gave you statistics, counters, IPFix for all of your networking devices, switches and routers. All of them are applicable to containers as well. So if you like to span traffic from a specific container instance, you can actually do that. NSX is implementing microsegmentation policy, right? Security policy for the application. But there are many people who are actually applying policy. But applying policy is a start, not a minimum required solution in our view. And that's what we learned from you. You need to have the ability to monitor the applied policy. So NSX has the ability to do statistics for each of the firewall rules. It has the ability to do syslogs for all of the firewall rules that are actually being hit. You saw Traceflow in the demo a second earlier. But what's also interesting is this use case with NSX Search. NSX Search has the ability to mix data coming from the application platform and the infrastructure platform to really enable efficient incident response. So what we're really doing is, for all of the infrastructure resources, we're tagging them with application constructs. So for a network that is servicing a cluster, we actually tag it with the cluster name, the microservice app name, all of the labels that were deployed as part of that application. So if you're trying to respond to an incident, some form of an incident, using the NSX Search, you should be able to filter in quickly, instantaneously, what are the small set of network resources that need to be troubleshooted to troubleshoot this application. We've also taken all of the logs that NSX firewall generates and integrated into LogInsight. We learned from a lot of you that you're monitoring microsegmentation policy using LogInsight. So what we've done is we've basically gone and integrated all of the NSX. So the health of the NSX system can be monitored. NSX container systems can be monitored from LogInsight, and also the microsegmentation policy can be monitored using LogInsight. How many of you are using LogInsight? Is LogInsight kind of quite popular? Okay, so that's pretty much what we learned, right? So LogInsight is your console for managing infrastructure, monitoring infrastructure. If you build a new feature, make it work with my existing console, and that's what we've done. What we've also done is having a single console for monitoring microsegmentation policy. So what you're seeing here is dashboards on LogInsight for all of the container networking traffic that is being allowed and denied. So you see there on the top right, there's a port scan that's happening from different IP addresses, and the container firewall is dropping them. So monitoring applied container networking policy is required, and that's what we've done. Okay? So now we'll introduce the next section, right, which is really integrating with existing tools and processes. So we've learned from all of you that most of the use cases that you're using containers and cloud native apps are not really for building massively new applications. We learned from you that it is for modernizing existing applications. The industry is calling them lift and shift. And we learned the same from other third-party market research as well. And we see that that is true even for quite some time, right? Where 50% of the cloud native apps or container projects are really modernizing apps, even in 2020. So what does this really imply is a lot of administrators said, we would like to reuse our existing investments in tools and processes, right? It could be load balancers, it could be firewalls for this new infrastructure. So we spoke to this large financial institution in UK. They said, you know what, all of my middleware is going to be running in Kubernetes-based PaaS, and I need to make sure that network services and my load balancing designs should not really change as I migrate to this journey. So it became really important for us to make sure that we work with existing investments. And that's where you'll actually see the NSX integration with F5, which Nick and Kent from F5, Nick and Kent will be speaking about.
Thanks, Sai. So as Sai said, the investment protection story really rings true here, and we just wanted to take a few minutes to show you some of the work we've done actually based off of customer request with our friends here at F5, how we've integrated F5 load balancing into NSXT. Let me click off the video here. Essentially what we're doing here first is looking at the YAML spec for what they call their container connector. So this is essentially, as you can see here, it passes a number of parameters to the actual big IP. There's a bunch of stuff in there, the URL, the admin credentials, etc., the actual namespace as well. And you'll see how that becomes pertinent a little bit later in the presentation when we flip over to the big IP UI. What we're essentially doing here is deploying that container connector into the Kube system namespace, and we're just watching that container connector be built. That container connector is, again, the sort of interface from our actual Kubernetes cluster to the big IP. The next step here is actually just a quick thing to set up the permissions. So the permissions within the cluster are set appropriate, so the actual big IP is actually able to see the systems in the namespace. I wanted to pause the video right here real quick just to talk about the topology. I know this is not an architecture deep dive on NSXT. If anybody is not familiar with NSXT, this may look a little confusing, but what we're doing here within the demo is essentially creating tier 1 routers for each independent namespace. And the two namespaces we're going to do, which actually coincide with Sai's previous demo, we have one called F5 demo and one called NSX demo. One is actually configured as a routed namespace. The other is configured as a NAT namespace. The most pertinent part probably is how we've deployed the big IP. In our situation, we've actually just using the software-based, VM-based big IP, but you could also use the physical appliance again if you have that investment already there. So we'll continue the video along here real quick. So this is the big IP UI. What we're essentially going to do now, as you can see in the back there really quick, there's nothing deployed in the system. We're going to go ahead and actually build the virtual servers for each application that we're doing. So we have one for our F5 demo, we have one for our app called Guestbook, and we're also reusing the Yelp app as well. So we're creating a virtual server for all three of those apps. What that'll do is actually create the virtual server in the F5 load balancer, or excuse me, in the actual UI, which we'll see here in a second. So we can go here and double check. There's our three virtual servers for those IPs. The actual IP that's represented up there was there, and you'll see when we go to access our application in a second, we'll use those 192.168 addresses to actually access our application. Those IP addresses that were displayed there are the members in the virtual servers, and those are the actual IPs of the containers themselves. So like I said, we just basically take those IPs from the front end. The applications have been built. I cut that out of the video, but we can go to our first IP address, which is basically our NSX demo container IP. The next IP address, 103, is actually our Guestbook application. And the last IP address there is going to be the same Yelp app that you saw previously in the demo. But essentially now what we're doing is, again, front-ending those applications with the F5 load balancer. Again, as I mentioned, it can be a virtual load balancer, or if you already have investment in the physical big IP, that can be reused as well. The one thing that Sai was just previously talking about, some of the monitoring and visibility capabilities of NSX, are highlighted in the video as well. So very quickly, as you can see, we have our logical switches that we created in the topology for our particular namespaces that we've deployed. I added this in here because I think it's very pertinent. He was talking about the unicast, multicast, broadcast, all the packet counters. That is something that I think uniquely defines us from a container networking solution within the industry. The other thing you can see here from an operations perspective, we actually map all the logical ports, the actual container names, to the actual interfaces that are on each individual logical switch. So in one interface or in one particular screen there, you're actually seeing the mapping from the individual containers, the actual container interfaces that are on the logical switch, and again, you can drill down and get those particular counters on a per interface basis as well as a per switch basis. Sai, I think that's it for me. Back to you.
Thank you, Nick. So we got a swap,
Yeah, 3, I think it is. There you go.
Good, thank you. Is this kind of valuable? How many people are looking to use like F5 or their traditional appliances for container load balancing? All right. A lot of people. So we're looking for guidance from you in terms of your specific topologies, your specific use cases. More specifically, Kent, who's like the very senior F5 solutions architect. He's here he's working with Nick. They're definitely looking for your use cases to take this work forward. Okay. So that was a little preview on how we're integrating with existing appliances. The next area that we really saw that was also required was reference designs. So we were asked by a lot of our customers in terms of how do we deploy applications that are sensitive to PCI or HIPAA and these type of applications on containers. What type of network security do you think is required? So in that area, we've done a lot of work, and I'd like to call upon Wade. Wade is a very, very early VCDX, number 15. Did all of the PCI compliant segmentation for NSX 4 years ago. He's done a lot of work in the space as well.
Hi. Thank you, Sai. So, I mentioned my name is Wade Holmes, and I'm a senior manager of the technical product management team, security solutions team. And so first, how many people here have gone through the process of needing to meet a compliance or regulation within your environment, such as PCI? So those of you who have know that that's a pretty challenging endeavor. And while we've talked about how NSX and NSXT can secure container environments, security and compliance is a totally different beast than security. You can be secure but not compliant, and you can be compliant but not secure. Reason being, compliance is a point-in-time attestation of your environment based on specific controls that are dictated within the specific compliancy. So, as Sai mentioned, a lot of environments are looking at being able to lift and shift existing applications and moving them into a container environment. As you lift and shift those applications, your compliance regulation needs aren't going to disappear. So you're going to have to figure out how do you meet this. And as you look at how you deploy a compliant application in a compliant secure environment, you know that compliancy isn't based on any one set of checklists, but it's based on a security assessor coming in, looking at your environment based on controls and precedent, and determining that your environment is actually going to meet the needs of this compliancy. So basically what we've done within VMware and within my team, we looked at NSXT and container environment with Kubernetes, and we engaged third-party auditor Coalfire to be able to validate the capabilities of NSX and NSXT to be able to secure containers based on PCI workloads and be able to provide the necessary segmentation for card data hole environments and non-card data holder environments, CDE and non-CDE, within a container Kubernetes environment. So basically, Coalfire came in, and a big part of this was to be able to both educate auditors and first educating Coalfire about the solution and capabilities, and then creating this asset, this white paper that Coalfire is going to publish in September, that actually shows the process of how the technology can meet the needs of PCI DSS 3.2. So why is this important? Because as you adopt new technology, regulatory and compliance needs are always behind, the QSAs are always way behind, and you have to be able to have some type of assets to educate them so that when your QSA comes into your environment, you can say, hey, Coalfire NSX team engaged Coalfire, a QSA environment, a global QSA environment, and they were able to attest the capabilities of NSXT in a container environment and this new technology and be able to educate your QSA. So what were the actual findings? Basically, Coalfire came in and were able to show that the distributed firewall was able to provide the necessary segmentation to meet PCI DSS 3.2 needs and provide provide the necessary isolation between CDE, a card data holder environment, and non-CDE, non-card data holder environment within a Kubernetes container environment utilizing NSXT. We also looked at the capabilities of being able to dynamically spin up new container environments, and based on the labels, the Kubernetes labels, dynamically create security tags in NSXT for on-demand security. And also there was segmentation and attack-based testing, testing the spoof guard capability of NSX to make sure that man-in-the-middle attacks can occur within the environment. We also looked at the capabilities of another technology within NSXT, distributed network encryption, which between virtual machine to virtual machine workloads, DNE, or distributed network encryption, allows for endpoint encryption. It isn't applicable in 2.0 for containers yet, but that's on the roadmap for containers, and is applicable for VM to VM communication today. So basically with this, you can look at this as you adopt containers within your environment and you need to be able to deploy them in a secure manner. You can also now meet the regulatory compliance needs and have an asset out there that's going to be able to work with your security auditors and your QSAs as you go through this process. A quick question?
Will we be able to run this type of audit recurring with the vRealize network insight?
So with VRNI, you would definitely be able to see your existing security posture, and that's definitely something that can help your QSA. But as far as being able to run an audit yourself, it's always going to be a third-party auditor that comes in to test the actual compliance.
Understood. Preparation for the audit can be an NSXT audit recurring.
So that is something you definitely could do to look at your existing posture and understand your level of segmentation within the environment to be even more prepared. Absolutely. All right, Sai.
Cool.
Thank you.
Thank you. All right. Thank you, Whit. So those were some of the basic tenets of NSXT 2.0 and the integration into Cloud Foundry, into Kubernetes environments. So we've been working with a number of customers in this journey in the last 18 months, trying to kind of understand the product, build the product, and we'll look at what some of these customers are actually doing. The first customer is one of the largest retailers in the world, right? They're trying to move a booming e-commerce app or website from a WebSphere-based application to Kubernetes-based PaaS. This customer is looking to use F5 and the direct layer 3 routing capabilities between F5 and NSX. So that is what is really interesting to this customer. So they do not want to have a VM in between, which does NAT, and that becomes like a latency point or a performance choke point. Because for this customer, latency, minimum number of connections, they all translate to lost dollars, lost revenue opportunity. So this customer is looking at NSXT only for the networking aspects of NSXT, the networking stack that we are building for containers. We have another customer who is looking to offer container as a service to their developers and to host some applications on the stack. This customer is again modernizing applications, doing it from WebSphere. This time, this customer is looking to run this on a Kubernetes cluster that's based on IBM, right? So what they're looking to use NSX for is really for PCI compliant segmentation. So PCI apps, non-PCI apps, the ability to segment, the ability to monitor, the ability to fast compliance. So two different customers been working with us for over a year, looking to deploy in the next couple of months. So to summarize, right? So Kubernetes and Cloud Foundry are really platforms for building these modern cloud-native applications. They enable the developer to build, test, and deploy applications fast, but a similar platform is needed on the infrastructure side. And the NSX can be that platform where you automate all of the networking, security, load balancing for the application. There is a lot of hands-on labs for NSX. If you have a chance, please try the hands-on lab. To learn more, you can also look at like our network virtualization blog page. You can look at the channel. There is a well-defined POC guide, right? So we've been doing a lot of POCs of late. The average time to do a POC is 2 days, but to be conservative, we plan for 3 days. There's a well-defined minimum set of requirements, right? It's vSphere 6.5 and a bunch of servers, and a clear definition of what type of test cases can be done with NSX. So you can leverage the POC guide and actually plan for a POC. If you are like an enterprise architect in the room, right, and you want to basically are defining the architecture for PaaS and CAS, you should look at some of our reference designs that actually come out, not just the PCI core file design, which is more security focused, but also on the networking side. If you're a practitioner in the room, the hands-on lab is a good start. Is a good start to learn at the technology. If you're trying to sponsor like some type of a POC in your environment, this POC guide is a good place for you to look and try to really understand what the product can actually offer for more executive type people in the room. If you have any more questions, you can always reach out to the NSX team, right? They're accessible here. That's pretty much it. If you any questions?